Welcome to another video of Don't Panic Geocacher, channel devoted to teaching you about mystery caches and hopefully help you solve some along the way. My name is Arjen and I go by Waterfan5 on the geocaching website, and I'm here today to talk to you about how pictures can be used to make mystery caches and to hide information for mystery caches. Many geocaching puzzles feature images, and images are a great way to hide information. There's lots of different techniques, and so this will be a very comprehensive video where I'll talk to you many of those techniques. I recently published a puzzle especially for this video, and it shows 15 different techniques to hide information. All this information can be used to hide information for a mystery cache, to get coordinates or other information. And I will show you step-by-step techniques of how you can get that information, how to utilize these different techniques, and how that can help you solve caches. Very common, I will use two different techniques, an online resource as well as a non-online resource, laptop for example. That way you can decide what is best for you and also maybe explain it slightly better. Because this is a pretty technical topic, I'll go in a lot of detail, and so if you have a question, feel free, of course, to reach out. But hopefully this will give you a good overview of all the different varieties that information can be hidden using images, using mystery caches, and we're trying to solve mystery caches. So there is a lot to talk about. Talk about information hidden in pictures. So to structure video a little bit, I'm gonna group them into four main categories. That is information hidden in pictures that's in plain sight. So when you look at the image, you can see, maybe you have to look closely, but you can see the information. There's nothing else done to disguise it, but you do, yeah, carefully. The second category is more related to using the color contrasts. So the picture may only have two colors. Tell you how two colors can come to a coordinate, or how color contrasts can be used to use that information. So color contrast is more that the colors are close to each other, and so the information like that is used so that you can't really see it when you look at it, but if you analyze it using some tools, I'm going to demonstrate some of those tools, that you can see information and you can bring information forward that isn't obvious otherwise with the naked eye. Third category is more looking at more technical information in the file. Images have a lot of technical information, names, sizes, something called picture exchange format information. So I'm going to talk about that and how that information can be used to store extra information. So all of these are still, call it, standard ways to hide information. The last one, steganography, is really on purpose hiding information. All the other ones, of course, are on purpose as well because the cache owner or somebody is trying to hide information. But here we're really trying to uh, encrypt information in there on purpose, and we're going to use attributes of the image to do that. So this is a more advanced technology for which tools are really needed to decipher that. Now to structure all of this, I've recently published a cache that uses a combination of all these things, and I'm going to use that to kind of guide you and demonstrate these different techniques. So I'm going to do it slightly different this time because of the complexity of this subject. Going to solve the puzzle into different segments, and then at the end we have every piece of this puzzle solved. So I actually published a special puzzle for this video. So it's called Lab with Egg Hunt. That's just the theme of the puzzle. And we're going to solve that one throughout this video. So classified as a 4, that's mainly because I give a lot of the techniques away, and I will link the video on the cache page. So actually somebody that's the cache page but hasn't looked at it can use the video to kind of guide them through this whole. Still think it's worth a 4 because there's a lot of effort you need to do. There's some flavor text, talks about a tradition in the Netherlands, about so-called Kievitseijacht, lapwing egg hunt, all about it, but that is just some flavor text, not relevant of this puzzle cache. What we do need to do is described here. We have to find numbers, and the numbers all have to come from this image below. And this image you're going to see a lot because it's the only image that we're going to use in this video for solving puzzles, and we're going to get 15 different numbers out of that, all hidden with different techniques. Now, look at this. You may already have some ideas. You may even see certain numbers already, and we're going to use all of that to get a bunch of different numbers. So in this case 15, but some of them have numbers associated. To make it easier, I have put in the cache page how you get those numbers. So you see here 15 different techniques, and I give you kind of like step-by-step instructions of what the number is that you need to search for, not necessarily telling you how to get the number. That still might be sometimes a puzzle. But it starts really easy, like for example, count the number of eggs. Very straightforward, right? We'll do that in a second. But it ends up being pretty complicated. Of the final steps, we're going to talk something about steganography, which is about hiding things out of plain sight in an image. So 15 different techniques, all going to use the same puzzle. And we're going to use it as an example later on in this video. But first, let's look at some of the techniques and give you a little bit more of theoretical background. First thing to do is look at the image itself. Look at what you see at the image and see if you recognize it, right? Because there could be a lot of objects on there that actually represent a number. I'll give you here some examples. So for example, planets. Planets can be ordered by size, by distance from the sun, and that gives the planets a number. So if you see multiple planets, then that might encode a coordinate. Maybe athletes on there, and athletes may represent the number that they played. Maybe it's the year that they got an MVP award. That's maybe what they have in common. Or maybe it's the first letter of the athletes that somehow need coded, or some other way to get a number out of athlete information. So what you do is you try to see if there are multiple things. If you look for coordinates, then we get back to the 10, 13, 15 digit numbers that you need to get to a coordinate. And so if you see 13 of something, it's a good hint, right? So, and I just give some examples here: presidents, countries, movie names, albums. These are all examples, right? So, and especially if you see multiple of those, then it might mean that they have something in common. Now, you may not necessarily recognize them. And in a previous image, I showed how you can do something called a Google image search or a TinyEye image search. So that helps you maybe find the information. You may not recognize the athlete, you may not recognize a person, you recognize something else. And an image search is a very useful tool. So in Chrome, it's a standard built-in feature, but other browsers have it as well. And if you don't have Chrome browsers, you can download the image and upload it back to Chrome search. If you want more information about this technique, then I really recommend that you look at the one, my video called Solving Mystery Caches, Google all the things. That one talks more about this technique. But it's really useful to just look at the image, see what you see if you can find some patterns, right? So in this example, I used it to cities that you see here because they were important for this puzzle. So that is the first thing that you do, is just look at the content of the image and see if it makes sense, see if it can help you solve the puzzle. And Google image search can be useful in it. The second thing, if it's not really representing directly a number, is you do what you do with anything that is like text as well. You do the same thing with images. Count everything that you see. You see different animals, count all the animals. Do you see matchsticks? Count the matchsticks. So anything that you see could be relevant and could be represented in a number. So if there is something to count, make sure that you count. The other thing is that the usual suspects also talk about some techniques, right? Morse and Braille are often used So see if there's something that represents the positive negative that you see in Morse and Braille, right? A 0 and a 1 or an A and a B. Because often in images they may simply just be a Morse code or a Braille cipher encoded in the image, but not as dashes and dots, but as something else, as monkeys and elephants, right? Monkey might represent 0 and elephant represents 1, and now it might be Morse or Braille code again. And of course it could also simply be characters or anything else that just represents either numbers, and so here we're looking for something close to the 20s, right? 26 different ones, or numbers, looking for 10 numbers. So you kind of treat the image the same as you would text, and you kind of look for these patterns in that image. And also here I recommend one of the other videos, Check the Usual Suspects, talk more about these and how to recognize them, what to look. But this is absolutely a thing that you should do, is make sure you count everything, make sure you do everything. So let's take a look at the puzzle and see how I use this in this puzzle cache. Okay, let's take a look and apply what we just learned. So here is our image again and our cache page, and look at some of the assignments that we have. Well, start easy, just count the number of eggs on the page. Can't emphasize enough how important counting is. So we see here a bunch of eggs, and you can maybe see they're slightly into groups, right? So one of the techniques that could have been used, it says, is simply the groups give you the coordinates, like 4, 3, 3, 3, 4. That could have been the coordinates, right? In this case it isn't, because I just tell you to count it. But many caches where simply counting will simply give you what you need, and maybe different things that you have to count. West, maybe different symbols that you see, and you have to somewhat put them in order, the symbols. But never, if you see things that are counting and you don't know what to do, I recommend counting things. In this case, we just need to count all the different. So pretty straightforward exercise, right? So we see 4, 3, 3. So 4 plus 3 plus 3 plus 3. So can't type today. Plus next line 4, 3, 2, 3, 3, 1, 3, 1, 2, 3, 4, 1, 4, 2, 2, 2, 1. Right? So 4, 3, 3, 3, 4, 3, 2, 3, 3, 1, 3, etc. etc. 2, 2, 2, 1. So this doing something that will calculate, and it says 54, and that's our first number that we need. So we have our first number solved, counted for x. This is a very simple exercise. This would very much be the final coordinate of any other puzzle, right? As I just explained, maybe per row you have to count something. It is the ones you have to order by colors, right? It could be the count the number of yellow eggs, count the number of pink eggs, count the number of brown eggs, count the black eggs. That gives you 7 different numbers, and that could be the coordinate, right? You look some shape of. So yeah, can't emphasize that enough. Always count things if there's things that to be counted. Very important technique when looking at puzzles. In this case, that's not the only technique that you mentioned. There's 15 techniques, and some of them are our usual suspects. So number 4, and the other 2 later on. Say, always remember the usual suspects. Can you find Morse code on this page? We're looking for 21 character text, giving you a 3-digit number. Okay. Back at the text. Can we recognize Morse code in this? Well, a lot of techniques kind of use this binary approach, right? We have 2 things that we have to separate, one representing zeros, dashes, and one representing dots, ones. Or if it's a bacon cipher, another binary cipher, A's and B's. But at the end, it's all zeros and ones, dashes and dots. Doesn't really matter what the symbol is. In this case, it is standing X and laying down X. So with Morse, that still would give us 2 combinations. One where the standing X would be the dot, one where the standing X would be the dash. so we may have to try two combinations. Some websites will try two combinations for you, but we were told there's 21 groups, and you already saw me in counting, you saw me analyze those groups, right? So we have this first group, which is, well, let's try one, dot dot, and we'll do the laying down one, it's a dash, then dot, then the next group would be dash dash dash, dot dot dash, and then dot dash dot, right? So dot dot dash dot dash 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 dot dot dash dot dash dot, and then the same with the next line. Let's see, it's dot 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 dash dash dot dash dot. Okay. So if we take this information and just use one of our decoder websites, so in this case I'm using Geocaching Toolbox, very popular website, put it in there, and we can see already 4 and then 100, basically the first part of 100, right? And that's, we're expecting a 3-digit number, so 400, get some more text. And so if we decode that, we'll get a 3-digit number, and we have solved the second part of our puzzle. We've solved 1 and 4 so far, using the usual suspects. The next thing you can look for, see if there is multiple images and see if you can make a connection to those images. First thing to check for is they are the same size. If they're the same width and height, for example, it's very likely that you have to overlap pictures and somehow see how those pictures overlapped can form something. Very popular is a so-called grill cipher, a cipher that kind of places on top of another one and then hides a lot of information, and only relevant information stays visible. You can also see where there is associations that can be made. Maybe one uses colors and the other one uses the colors in a different way. Maybe there's a connection and kind of create a link, like what is red here, and the other one explains what red means. So if you want an example of that, I would suggest to look up videos Don't Give Up, number 8, and number 9, Be Organized. They use this technology and this method in both of those videos. And then, of course, when you have looked at all of these things, you've compared the images, you have looked and see at the image itself. Now start zooming in closely. So start looking at every inch of that little picture, maybe open it in a window, maybe open it in the browser, and zoom in, zoom out. Make sure there is no small text hidden anywhere. It's a very popular technique, it's easy to do. Just put some small text on there in a color that is hard to see, so it becomes kind of like shaded or camouflaged, often in a busy area where it's easy to overlook. It can also be made very small. We can have very tiny text. So make sure to zoom in all the way. I use a tool called photo forensics that kind of like highlights those areas that kind of stand out, where something might be hidden. It just makes it easier available. It doesn't capture all of it, but it does capture a lot of it. Let's look at some examples. So let's practice what we just learned. Two techniques here. One was called like shaded or camouflage numbers, right? I didn't camouflage it in this case really well, but let's just take a look. What I always recommend is take the image, open it in a new window, so like this, and we can now use the browser to zoom in and out. So zoom in all the way, we can kind of like look at the different areas, and you may notice that there is a tiny number hidden here, right? It's actually pretty hard to read, but the cache page helps us a little bit. We look at our specific assignment, then it says look closely, we look for a 10-digit number, and it's some arrangement of these numbers, right? Kind of helps us forward. So if we take this and open this in the page, then we can see we have a 1, we have a 3, we have a 6, we have a 1, be a 0 or an 8, but we don't have an 8, so it must be a 0, 7, where is it? 2, oh, we already have a 7, so this must be 2 then, 3, 1, 7, 5. Still something wrong, so because I already don't have a 5, so this must be a 9, right? So 1, 6, 1, and so on. So we can kind of verify 1, 0, 3 ones, 1, 2 threes, a 2, 6, a 7, and 9. So that's a very tiny number. Of course, if we had zoomed out, we couldn't really see that number, right? Or it becomes much harder to see. We can see that something maybe is there, it looks slightly odd. But the more we zoom in, and especially if you're on a phone or something, which I never recommend a puzzle on the phone, we can see that very easy to miss. A pretty obvious number here in the corner as well. So that's more of a shaded number. Made it pretty big here. Kind of contrast, but even if we zoom again, let's do that. You can actually see that the more we zoomed in, it actually is harder to see. So sometimes you may actually have to zoom out to see it, because now it might actually be easier to miss. But if we zoom out a little bit, it actually becomes more readable. So zooming in and zooming out may actually help you getting that information out. Now, this may still not be enough, so you can also use some tools to do this. So I'm using two. First one is photo forensics. Let me actually start at the beginning because it's pretty straightforward to use. So clear this out. If I most cases you can simply say copy image address, go to it and just paste it in here, and that will take care of it, and it will upload the picture to this website for further analysis. The fact that I get a pretty strange address, not a geocaching.com, is actually going to be a hint later on. So normally you would expect it to be hosted on geocaching.com. This one is not. That actually is a hint. And what this website does is it does a bunch of information. I'm going to use it several times here through it. But one of the things it does is kind of like identify anomalies. So here you see the picture, and suddenly you see like a red area here disappear. It looks slightly off, right? Because the rest is kind of not red, and then here suddenly there's a red, indicating that this may be an area that we have to pay more attention to. And that is the area where indeed that tiny text is. Note that the shaded text, it kind of detects, it shows a little bit more blue, but it really doesn't really detect the shaded text in here. But it's a good tool to kind of detect if the image has been messed with. Notice it detects all the X pretty easy. It says like, the X looks suspicious. Same as the other text, right? So there's other websites that do this. I like photo forensics. I'm going to use it for several of the techniques in here. Another one is Perisolve. You may have to download it first to your machine and then upload it to a Perisolve. And it will again detect a lot of different techniques how an image has been messed with, and I will be using it for a variety of ones. But in this case it does all these different color patterns that it does, and it shows all the picture in different color combinations, and some of them will actually more clearly identify this number, right? So here on this one you can see the 2397 even slightly clearer. So when you have an image and you expect that the image has been manipulated in some ways, these two websites, Perisolve, Photo Forensics, are good. And so you saw here that 2397, the shaded or camouflage number, pretty easy to spot here. And then the tiny number, you just solved that as well. But in Photo Forensics, kind of could help us pinpoint where it is located. Going back to the puzzle, that means that we've done the shaded part, the 4-digit number, pretty easy to see, but still some tools that can help us. We also have the 10-digit numbers, and I gave you the 10 numbers since some of them may be harder. So yeah, two more numbers identified. So we've now done the first 4, 11 to go. Still very much in plain sight are the colors that are used on the page. This often indicates that either a value or a sequence that you have to look at. There's very popular methods that are being used. Think of the colors of the rainbow, Roy G. Biv colors, but also colors of resistors, the black, brown, red. Those are all sequences of colors that represent values or orders in which to interpret something. But there's many other variations: pool, snooker. I've seen elevator colors used at like a field puzzle. So colors can be very significant when looking at something. And make sure that you evaluate the color both as a value, for example, red in a rainbow is the first color, as well as it might mean that if it's red, it is the first number. And sometimes it could be both. So it could represent both a number and um, a color. For example, if you see a red hand, the hand might represent 5 as the fingers, and red might be this is the first number, the number is 5. But it could also be the other hand, all the way around. 5 is the sequence, and red means the value, it's number 1. So colors create an extra dimension, and it's good to take that into account. And again, let's take a look at some examples. Okay, again, let's practice what we've just learned. So here's our image again. And it says here, are you familiar with snooker? Remember those Morse code numbers? Well, the same sets are made to make 21 composite numbers. So before we had 21 letters, same sets now make 21 numbers. We have to sum those together, so we have to get 21 numbers, and then it also gives us a 5-digit number, and the checksum should be 12, right? This is ways to verify that we're not screwed somewhere. Just to help you along. So yeah, let's look up what we can find about snooker. So I would say typically for pictures, rainbow is by far the most common one used. So if you see 6 or 7 colors, probably rainbow. But rainbow doesn't have, in this case, black, and so in this case brown. So rainbow it's not. Resistors is a very popular one. I already showed some color combinations that one has. Gray, brown, black, so it could have been resistor colors. In this case, I tell you snooker colors. Often this might also be used for ordering, right? Because the rainbow has a specific order. Resistors kind of have a specific order. In snooker, it's kind of like a variant of pool. They have a certain order. So it could be used for order in addition to values. And that's often you see combination where maybe the colors are used to order things, especially rainbow, 7 numbers, a lot of coordinates. Have north and west have 7 numbers. Might be popular to use. So take a look at that. In this case, we're actually looking for the specific value, right? In sets. But it could have been that if I had to count all the red ones first, that would give me a number, then pink ones, in this case all the yellow ones, all the green ones, and that would give me 7 different numbers. And that might be a coordinate, right? In this case, that was not our assignment. We simply have to figure out what these 21 numbers are, right? So these groups that we have all create a number. We just need to figure out what do these represent in snooker. Well, snooker is a variant of pool, so the table is twice as big, or at least twice as big. I think it might be more than twice as big, and the balls are half the size. So yeah, not recommended to play while drunk. A much bigger table and smaller balls make it a much harder game in that way. But you see, there's nice little colors, right? Red is 1, yellow is 2, green is 3, brown is 4, and so these are the colors that are of the eggs. So again, ideal to use because it allows us to represent a lot of different numbers. There's also a white ball, which could be 0. So now that only allows us to not 8 and 9, right? Gives us a lot of different colors. So popular in the UK, but a lot of Europe they play it. So yeah, let's take this information. So red valued as 1, black valued as 7. I'll copy that so that we have it as a kind of like a cheat sheet when we, and then go back to our picture that we see right here. And now we can make those 21 composite numbers, right? So black is 7, green is 3, yellow is 2, and blue is 5. One number, 21 of those. Pink is 6, yellow is 2, red is 1. Second, yellow is 2, green is 3, brown is 4, so on. So red, let's do one more. Red is black is 7, and yellow is 2, and then do the next one. 2, 1, 6, 2, so on. So basically 2, 1, 6, 2. Next one was 7. Blue was 5, 6, 5, 3, and so on. So we get 21 numbers. We have to count all of those together. So we do one big number that gives us a 5-digit number. So we can easily see there's several ones that are in the thousands. So that's how we end up with a 5-digit number. If you, let's say the number was 1, 2, 3, 4. This was our number. The checksum you have to calculate. So you see that in puzzles a lot that they say they give you a checksum. Simply add the digits together, right? So it's 2 plus 1 plus 3 plus 4 plus 1 plus 3 plus 4 plus 5 equals 6, 10, 15. So the checksum is 15. And in certain cases, they may want to reduce it to a single digit. So the single digit would be 6, 1 plus 5 again, right? So in this case, I gave you this number, but I gave you 22. So we know that if I would have gotten this sum, it would be incorrect. It has to be something that add up 22 as a checksum. That's what we, sorry, 12 as a checksum, not 12 as a checksum. So this one clearly is incorrect. Doesn't mean that the number needs to be lower, it could be a higher number, right? So for example, this only has a checksum of 4, even though it's a higher number. So we need to, allows you to verify whether you made a mistake in counting, since we have to add 21 numbers. Pretty easy to make a mistake, so makes it slightly easier. But again, this is how colors can be used. Again, could have been used in 2 ways. It could have been that we had to count all the red, count all the blue, maybe multiply them by their value of what it is, right? In this case, I told you snooker, rainbow, resistors, but there is many other ways to define colors. I've seen elevator colors being used for puzzle. Every floor had their own color. Resistor numbers, pool numbers, there's safety numbers, there's all kinds of numbers that have colors. I gave you that checklist in one of my previous videos, I think organized. That checklist shows you a number of different examples of colors. Another popular one is like computer colors. There's 15 computer colors that were used in all-time computers. They all have a number, so that could be used. So if you do see different colors, it may be used for ordering certain numbers, but it may also be a value. So figure out the order. That may allow you to put something, the numbers in order. But it could also be that you have to multiply by that number, or use that number in some other shape or form. So yeah, that was the color part. The last part of the in plain sight section is the 3D part. Now I show here a very popular way of 3D, so-called stereograms, where you have to kind of like stare at the image and hope that you see something. There's fortunately online tools that can help you with that, and depending on what it is, it might hide a number or it might hide an object that you need to cache. But when you look at an image and you don't really see what's going on, don't forget to think of it as a 3-dimensional image. It doesn't have to be a stereogram, it might be something 3D that's represented as 2D. I've seen several puzzles like that, and so don't forget when you look at an image that they might try to trick you and show you something that's actually 3-dimensional. Also here I have a sample, you may have already noticed in the puzzle that there was kind of something like that going on. So let's go through that and how we can decode. Okay, so take another look, and all the way down it talks about stare at the image. If you're good, you see 2 words forming. 2-digit number. It's called a stereogram. Don't see it, use a tool. So let's look at the image. Now, typical giveaway for a stereogram is these bars in the image, because it's kind of like just a repeating image and then kind of overlays it to create a stereogram. Now we can all stare at it for 10 minutes, see if we see it, or we can use a tool. That's what I did here. So this is a Magic Eye website, link in the notes. And I uploaded the picture either through URL or from your hard disk, depending where it is. And you can upload the image. And now there is this bar that allows you to zoom. Now by default, it typically already goes to an ideal part, so it detects it for you. Now kind of showing you how this works. So kind of like see it kind of overlaying it and then comparing it. And then suddenly, if it hits the sweet spot, you suddenly see numbers appear. So you see that right here, we see partial ones. So you see here, I, X, I, V, E. Clearly there is something here, right? But suddenly if I move away again, then suddenly it's invisible again. Now we can see the other part. We see here an X, I, an F, I, V, E, right? So we get 6 and 5. So, but yeah, this could be any image. It could be an elephant, right? And we have to guess that it is an elephant. But this is just one way that, again, something could be hidden in an image. It's a stereogram. And as I mentioned, the typical giveaways are these bars. It's not the only 3D part. Sometimes an object can just be 3D, right? I mean, you see here some things. This could be something that is flat that I have to portray. Maybe this is a square and this is a triangle, right? So don't take 3D out of the equation. I've seen parts where I had to fold things into, so I had to print it and fold it into like a circle, and kind of like, if I now looked at it, it would kind of like show something in 3D variation. So even though it's a 2D image, don't forget to think about 3D as the potential solution problem. So now that we've looked at all the in plain sight ones, we're going to look at slightly technical elements, and that is using the color contrasts to hide information. The human eye can only distinguish so much difference in an image, but the computer can distinguish lots of different variations in colors, and that can be utilized to hide information. Very popular is to hide the information in the background area. If you see a plain area that looks plain white, especially if it matches the background color, it's a good candidate where something special is hidden. Many applications, like editor applications like Photoshop, GIMP, other information, I'm going to use Pixlr later, have options to kind of like fill or use a bucket tool. And if you use that with a very low threshold, like 0 or 1, it can expose minor differences. You can also use tools like photo forensics that will highlight it as well. You still have to zoom to the area, but it will kind of like highlight areas where minor differences are there, and it will kind of like make it more visible to you. I'll use both techniques and show you how you can use that. That is in a plain background. So you always look for plain backgrounds. If you see plain backgrounds, you kind of like try the fill bucket function and see if anything is hidden. Much harder to see is the hidden in the foreground. Especially in text, it's very easy to make one letter slightly different color than another letter. Fill tool doesn't do anything because it will stop at the edge of the letter. So you have to use a more advanced tool like a color select tool. Not all applications have this, but I will do a demonstration of that as well. But fortunately, there's also online tools like Aperisolve that will help you highlight that type of information. So I'll show you ways of doing it. Another way to do it is by kind of using the fact that we are not colorblind, or maybe use it against you if you're colorblind. And so you can hide information in different layers, like most computers use the RGB, red, blue, green, red, green, blue filters, and as layers of colors. TVs and so all the TVs work that way as well. And so what you can do is kind of say, well, I hide only something that's only visible if you eliminate all green, or if you eliminate all blue, or if you eliminate all red, then suddenly something becomes visible. Again, it's a clever way to hide something in a puzzle, and so you have to play with hiding those filters. Fortunately, there's also tools, and again, a Perry solve that for you, so you don't have to know what to do. It will automatically show it to you if there's something like that hidden. Very useful going. So let's look again at our puzzle, and let's take a look at what we see with these techniques. So what do I mean when I say color contrast, right? So I talked about foreground and background. Well, I used both techniques in this picture. And I'm going to show you two techniques, one with online tools and one with we downloaded some tools to do as well. So we see here an image and nothing out of the ordinary, right? We've already found a bunch of numbers, but there is more numbers. And I'm using the same two tools, the photo forensic and Perry solve, to find some other numbers in here that are hidden. And later on, I will use some other tools as well that you can download that can do it as well. So if I load it in here, so upload the file, we already saw that it was able to detect some numbers, but you notice that maybe if we look at this picture, suddenly this white bar is there at the bottom, right? When we went back, we didn't see this white bar because it blended in with the website. It's the same color as the website. Did that on purpose. But if we look at our assignment, then it says numbers can be hidden in the background. And so we're looking here for a 12-digit number. So somehow there is a 12-digit number. And I also use slight variations in text colors to spell out the hidden text. A fill tool won't help. See, a fill tool may sometimes solve it. See that later on. But we also hid a 4-digit number spelled out. So we see here text. Somehow there is a 4-digit number spelled in there, right? These tools can actually show it for us, and then later on I will use something called GIMP, but you can also use MS Paint or Photoshop or Pixlr or some other tools. Same things. But why do the hard way when you can do it the easy way? Let's do the easy way. So photo forensics is able to already detect some numbers, but we see this white area here at the bottom. And now let's take a look what happens if I do this one, right? Suddenly it shows in this white area, and let's open it again and new tab and zoom in a little bit more. We can now clearly see that it exposed a number that was not visible at all before, right? 7398473982113. So yeah, this number wasn't hidden, wasn't shown at all, but why does this tool show it? Well, it's because when I made this picture, I used colors that were so close to each other that the human eye can't see it. They literally were only like 2 numbers off. So if you think about that, the numbers of colors go into the millions. It's 255 times 255 times 255. Pretty big number. I used two colors that are so close to each other that the human eye really can't see it, but a computer can. And this tool is basically made to expose that, right? It says, hey, there is something here. And I'll make it very obvious to you that there is something that is here by emphasizing that. And so that's what photo forensic can do. It can show you those hidden numbers that otherwise would be hidden because of slight color variations. Very low contrast difference in the colors, in this case in the background. Now, how do you detect this? Well, you can of course use a tool like this. The other hint is if you see some very clear plain background, right? And it couldn't only be the foreground picture, it could be the background picture, right? I could have taken the background picture and hidden it there. You see some plain black background out. It might be that the hidden text is right here, just not visible with the human eye. And I would have to download the background picture, put it in a tool like Photo Forensics and expose it. But it has to be a plain text because otherwise we get this shaded effect and it actually makes it visible. It's harder to hide. But in this case, I can just use a single color, make a slight color variation, use these fill tools, kind of say, expose it, or we can use a tool like Photo Forensics. I'll show the other solution in a second. But this was only one of the two numbers that was hidden. There was also a number hidden in this text that is there, right? So it told us in the text. But here you see that photo forensics cannot make this number visible because it simply doesn't detect that anything is wrong. It only detects if something is wrong, if it's a plain text. However, another website can. We use the Perisolve website here, and it has all these variations, and it shows a bunch of different variations of these image, right? In all kinds of, puts it in red layers, blue layers. This is great if something is hidden in a color layer, right? So saying like, oh, you can only see it if you look at this color, you can only see it at that color. And you notice maybe in some of these pictures the letters look weird. So in this one we see that there is some black dots in here, right? And if we go up here, we see the same thing here and the same thing here. Because I used the same trick. Some of the letters I wrote in a slightly different color, again only 2 off in color scheme. So very hard to detect for the human eye, but a computer tool can do it. And especially if we use a filter, then it can very easily see that. And so in this case, the program uses the filter, and now it becomes pretty obvious that there is variations. And now we can read that what wasn't visible at all in the original image, we could see ONE 1391. So a 4-digit number was hidden in the text. There's your 4-digit number. Of course, I could have hidden an entire coordinate this way, right? Impossible to see for the human eye, but with a little tool, pretty easy to see, right? This tool, nothing, doesn't show at all that there is a difference. But in this tool, very obvious that there is a difference. So this is how tools can help you. If you didn't know it was hidden this way, the only way to probably find out is to run it in a tool like this, and it would tell you. But yeah, it's a puzzle technique that I've seen used in a variety of puzzles. Okay, so I opened the picture in Paint. So download it to my machine, open it in Paint, and we see the giveaway, right? That extra bar. Now in Paint, use the fill bucket tool, and if we use that anywhere on this white area, it will fill in everything that's exactly the same color, but only exactly the same color. And now you see when I click somewhere, it fills in, and we now see the letters clearly exposed. The letters that, or the numbers that were there, were just hidden right in the image, and we clearly see where they are, right? So you can just click anywhere in this area, and even if we clicked right on the letters, for example, it still would expose everything. It would just expose that one little digit there, right? So it doesn't really matter even if you're unlucky and click where the text is, it will still reveal it pretty quick. We're using the fill bucket tool. However, that doesn't do you any good with these letters. So for that, a tool like MS Paint becomes pretty tricky. You try to use the color sample tool and sample all these colors and write down the numbers and see which numbers are varied. Very hard, not very easy to do. But there's some other editors that make it pretty straightforward. Let me show you those as well. So this is GIMP. It's a graphical editor that you can download. It's free for non-commercial use, and it has some of the same features but also some more. So it has a bucket feature like we did before, but if we go here through the options of the bucket, we can set kind of like the threshold, right? So if I put the threshold too high and I would click on the image, we see it fills in everything. But if I put it very low, like at 1, and I fill in here, you now see that suddenly it exposes the number, right, that we see right here. This one, because it's so low, I have to click multiple times, but we see the same number appear, right? And if I go back, like the beginning, it was very obvious from the beginning, even if I used any threshold, that there is something going on, something special going on, right? And we can just carefully carve out the number that we're looking till we get like this 10-digit number that we're talking about. So same tool can do the same thing as what Paint does. slightly more clicks, but it uses the fill bucket. However, this one also has another tool, and which is the color select tool. So if we go by here, we can do a color selection. So selection, normally you select like things like by area, right? So you select a certain area of your image, and that's the area that you want to talk about. But sometimes you just want to select something of everything that is the same color. Now let's do that. And I selected here to say, well, sample everything that is within the same area. Again, put my threshold very low. And now when I select this, you see that it selected all the letters because they're all the same letters, all the same color. But it didn't select the ones that were of a different color. So the ones that again were slightly off. The eye couldn't detect it, but the system says, no, 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 that's not the same color. The threshold very low. And we see now that indeed exactly the numbers that we didn't want are now not exposed, right? We can also do it the other way around. Now that we know that this O is the one we need, we can kind of not select anything and just select the O. And now we only see the numbers that we're looking for. Zoom in a little bit, make it easier. And we can now see, hey, O, N, etc., E, T, H, R, E, right? Like 1, 3, etc., etc. So tools like this can also help you. I typically use the online tools, but here you see how editors can do the same trick, and all by using the color variation, right? We also have the color sampler here. And so if we would sample the colors of these, then we see these are 72, 72, 72, while the other one is 76, 76, 76. So very close to each other, a minor color difference that we see here. So that was the trick that was used here to again disguise, in this case, the foreground, where the fill tool didn't help you. Now, lots of information with colors. We've already seen different variations of colors can be used. We've seen slight variations of colors. With a very simple scenario, and I've seen, for example, puzzles where they just show two colors. One color represents west or latitude, one represents longitude. Because colors on a computer have a unique number, and in the image that number is saved. So you can use any editor tool. Now we'll use an online one so that it's available to all of you, to kind of like get the color information, convert that to a decimal number, and that decimal number now represent a coordinate or part of a coordinate. So it's very straightforward information, especially if you see like an image that only has two colors and the colors look a bit randomly chosen. They may represent a coordinate or part of a coordinate. It could also be that just this one pixel that is somewhere that looks off. You have a sea of green and suddenly there's one red pixel. Well, that red pixel probably means something. So take a look at the color information and see if it makes sense as a number. So we're going to use this as well. And so we're going to take a look at our puzzle again and see how we can utilize this information. Okay, so we're going to look at how to get the color of something. So that's either the HTML code of the color, or typically that will become a hexadecimal number that you then have to convert to decimal. It can also be calculated from red. That's the only thing you have. You have to multiply the numbers. But most applications will just tell you the hexadecimal way. So I'm going to use a tool called Pixlr. That's just a website. So pixlr.com, and loaded the image in there. You can load it URL or save it to your machine and load it. Now, what it said in the assignment, if we look, that we want the color code of the number hunt, right? So the number hunt text. That is right here. So I can click on there. And when I click on there with this, so I use this tool right here, the color picker. In every tool it will be called, sometimes called sampler or color picker, called something different. But if I click on it, then it will select the color. So if I click somewhere else, you see the color change. So this is the one I want. Now when I double click here, it will give me a number. So here's the hexadecimal number for the red, green, and blue number. So copy this one. We just need to convert it now to decimal text. So I'm using here a website called Rapid Tables, many different variations that you can use. Say hexadecimal number, and here we have a number. Now, just as a checksum, it says it needs to be 29. So let's do a quick 2 plus 9 is 11, plus 8 is 18, plus 3 is 21, plus 6, 27, plus 2 is 29. So checksum is 29. So there we go. We know that we have the right number, and we got another one done. So yeah, I used Tool Pixar here, but again, I could have used GIMP again, MS Paint. They all have this color picker. You can colors. Seen it often used in images and stuff like that, where you have to get certain number, certain color. Sometimes it's one color represents the east, sometimes or longitude, the other one may represent the latitude, especially if there's only two colors in an image. It's an often technique that's being used. Another way that an image can represent information is the file name itself. I've seen many puzzles where the file name gives you either a hint or a solution to the puzzle. So it's important to look at the HTML, the underwater like code behind the page, and see if there is anything there that tells you about the image name. Note that it doesn't always work. In the puzzle that I created, you can't see it in the HTML text, but in a lot of other puzzles you can. So I know in the introduction video, the introduction to mystery caches, I show the underwater technique, and so I recommend always to do that. And certainly look at the picture names. See if there is tooltips. See if there is extra information on the picture that is only visible when you look at the HTML. Another easy way to do it is simply try to save the picture to your machine. Save the picture, it has to give it a file name. And certainly if the image has a file name encoded in it, it will be exposed when you save it. So I will show both techniques with some information as well. So for using the file name, typically you would go to the HTML text. So I've shown that in another video how to do that. Right click in this case, do sort. And then there's multiple places that you can look for an image. If it's the background, search for background and you get the location of the background image. Or you search for long description or short description. So you see here short description, long description. And here you see all the HTML text, and we see here the link. Now in this case, you see that it is here on a Google Drive. This is, as I mentioned already, a hint that there's something going on. That's right. If you see something not stored on geocaching.com, could be a variety of reasons, but it is a good reason to start looking deeper into the image and see if there is something that has been done with the image that is the actual puzzle. So sometimes you can already find the name here, but geocaching.com names it, so that wouldn't be used here. But since I stored it somewhere else, I can still use a name. Now, this is not the name that we want to use, but I could do a save as, or what I can also do is I've used that technique earlier, where I say copy the address, I put it into photo forensics, for example, or any other website, and open it up in there. This will force the document to actually be downloaded and expose its real. So in here is actually the real is encoded, but you normally wouldn't see it until you actually start downloading it or opening it in an application. And we see that right here. So if we go now to the image, we see now that file name is a number and a P file, right? So this was actually the image, and so we can here find the number that is in the image, that the image is its own number, and this is the number that we. As I mentioned, the other option was to do save as. I will show a screenshot. Now, as I mentioned, you can also do it with a save as. So here are some screenshots of what it would look like. So you see when you save the information, it will automatically pop up with a name. This actually works on a phone as well. try to save the image on a phone, this number will automatically pop up. So it is platform independent the way that this is encoded. Of course, after it's saved, you will see the number, the same number already there. So this is another way that information can be encoded that you need to coordinate. Any image has a size. Size can be two variations. It's either the height and width in the amount of pixels or just the file size of the image. And both of those can be used in accordance. File size can be tricky because as a maker of a puzzle, you don't control the file size, but you do control the dimensions, how many width and how much height. And that could easily be converted to like a longer latitude, especially since most of heights of pictures are in the hundreds, a 3-digit number. And so if you think about the last 3 digits of a coordinate for the longitude and latitude, the size of the image in the height and the width can be very important. But it could also be the actual number of bytes. And so it's important that you're able to find out this information. Again, I'm going to show you different techniques. I'll use the website, the photo forensics website again, but also using save as, you can say the same information. Now let's take a look at the assignments. So we did already a variety of ways, right? So the image has an 11-digit file name. So that is already there. It's encoded in the source code, but you can try to save the file offline, as I just mentioned. But there's many different ways. So let's take another piece of information, and that is the size and the dimensions. So we see here the height and the width of an image can be they're often 3 digits, so that's ideal for like the last 3 digits of a coordinates. Or maybe you have to multiply them, that gives you a larger number. You can also use the file size. The image also has a size, not a kilobytes, that's typically a longer number. Again, that can easily be a 7 or an 8-digit number. Those are two other numbers that could be used in a puzzle. Sometimes you just have to guess that's what is used, but sometimes you may get a hint that this is the information. So already showed you photo forensics. Well, it shows you actually a lot more information about the file. So if I go back in there, open it up. If we scroll down, we see here the dimensions right here, 77 times 600. That will be the number of pixels. And that was the number that we were looking at, right? So we have to calculate how much 773 times 600 is. That will be the first number that we're looking for. It also asks for the file size in bytes, and you see that right here, file size in bytes. You can also download the file to your machine, and then Windows or the operating system that you use will tell you both pieces of information as well. But even if you're on the phone, you can see there's websites available and allow you to get all this information. So in most cases, I don't save the documents to my hard disk. I use the online technique to get the information, but it's certainly possible when you save it to look at the file size. So I highlighted it here, or if you go to the details tab to look at the pixels, like the height and the width. It doesn't tell you which one is which, so you kind of have to know which one is width there and height there. So below it, you kind of have to do that. But yeah, this is certainly useful information. And like I said, if you only look at 3 numbers for each, this is a great way and easy way to hide information, very controllable by the cache owner. Now, like I said, there's online tools I showed you. I typically prefer that. Certainly you can do it by saving and having this information available. So another popular technique is the EXIF information. So the dimensions of an image are fixed, right? So that means that if I upload it to the geocaching.com website, my height and my width is fixed. The file name, however, gets changed when you upload it to the cache. So you can no longer do it. The same is true for this EXIF type information, exchangeable image file format, that gets lost if it's uploaded to geocaching.com. So for this to be used in a puzzle, it needs to be hosted somewhere else. Note that when you download the image, some of this information might be visible to you. I would never rely on that. That information is very unreliable because it's operating system independent. So on an Apple and a Windows machine, it will show different information. It may not show all the information. And I will show that in my puzzle. So in this case, if you think it's this information, I always recommend you. I will use photo forensics again. There's many tools if you look for EXIF information. Decode website has it. Geocaching Toolbox has it. Many websites can read this information. But there is a lot of information there. And so you have to carefully scroll through it because it's easy to miss. And I will show you this in my puzzle. I use this as well. And I will show you how to do this. Okay. Assignment number 9 is related to this EXIF information. So this exchangeable image file format information. In this case, for this puzzle, there is a 30 number hidden in there, but you can hide large pieces of text in there, and many puzzles do it. So checking the EXIF information is a pretty good way. It's a pretty easy way to hide a lot of information in a puzzle. Again, can't be hosted on geocaching.com website. It has to be hosted somewhere else. But if it's hosted somewhere else, make sure to verify the EXIF information and see if there's anything. In this case, I would recommend using the operating system, whether you have Windows or Mac or something else, will tell you, but it will tell you limited information. There's often a lot more information than the operating system. And often also the operating system may give you differences compared to Mac versus Windows. That is not a reliable way to do it. I would recommend that. Here I'm just using the photo forensics site again. There's many other sites that do the same thing. If you look for EXIF information image, if you have another site that you want to use, that's fine. Many sites do it, but here I can go to the metadata, and here it will show me more information. And you see here under EXIF information, you see here the number that we're looking for, and the text congrats. And you see here it's just a flexible text. Now, this is just part of the EXIF information. Lots of different things, including coordinates. There's a system for coordinates in there. So there could be lots of different ways. So you kind of have to go through anything that it shows. It can show camera information, layer information, description information. There's a lot of variation that is possible that can be stored in here. So here I use the description information. But that is just, you have to check this entire section and see if there is something that you could be a date that is disguised, could be anything. So always check the EXIF information for more information. I made it, in this case, pretty easy. Just use the description, but it could be more encoded in this information. A normal image won't have this. So if you see this information in there, probably there's something going on. At least, for example, you may see that it is being edited. It may say, oh, this is Photoshop, was the last one to open it. Then you know, oh, this image was manipulated somehow. So always good. Look at the EXIF information. Now, as mentioned, this file had EXIF information. However, when I downloaded the file, it never showed it to me. This is because indeed it is system dependent. And dependent on where it's stored, you can actually use latitude, longitude, details, camera. There's so much information out there. It may or may not show. So I would not rely on downloading the file to get the EXIF information. I would always use an online tool. Otherwise, you may not see what the cache owner intended to see. And now we get to the final section, steganography section. This means that something is modified in the file with the whole purpose of hiding information. Of course, all the other things were hiding information as well, but this is the most technical aspect of it. I'll discuss two techniques to do it. One is by simply adding information to the file, adding extra bytes. Again, geocaching.com cannot do this, so if it's on geocaching.com, you know this technique is not used. However, if it's hosted somewhere else, it's a good hint that this technique might be used, or any of the other techniques that potentially work. And the simple way to see that is if you have a file, the file has a certain length, you can actually copy extra information behind it and the file will still work in the browser. The image will still show. So what you have to do is either save the file and open it in an application like Notepad, something that can read the file in a somewhat plain text format. Typically scroll all the way to the end. It could be at the beginning, but almost 100%, 99% of the cases, it will be at the end. And then see if you find any special text there that stands out. Or again, you use a tool. Photo forensics is one. I will show some other ones that can do the same thing. But you browse to it and you see if you find this extra information. And often, fortunately, these sites will tell you that extra information is there, so that it was placed there on purpose. So again, let's take a look at an example. And now to the more complex parts, right? So let's look at the assignments and let's look at the one for about extra information in the image. So number 10 says, so many ways to hide numbers. I literally just copy text after the end of the file and hit a number. It will be obvious once you find it. So you could open the file in, for example, Notepad or any other text editor. You'll find it, but you may not be. May have to do it on your phone, and so I often like to have a website approach as well. So just going back to the photo forensics that several times. And this has an option called strings. And if we go to the strings, it kind of like shows me all the text or information that looks like text. And if we go all the way to the end, we'll see that it says data after the end of the PNG. It's the file format. And then again, we see, congratulations, you found the added text. Then we see the number. So this is yet another way to hide information. So not EXIF information, just information behind at the end of the file, and you have to search. Note there's lots of what looks like strings in the file, but typically you will find the information at the end. There is some ways to hide it at the beginning, but I would say in most cases, if you check the beginning, you don't see anything, go to the end and see what it is. So that is the extra information on the website. So yeah, online tools are great. I highly recommend always to use online tools because they work on the phone, when on the road, you can always do it. Right? However, if you're behind a computer, certainly recommend solving puzzles on a lot of cases. If you save the file, so you see here I opened the file in Notepad, and you see kind of at the end, you see that same information behind the file as well. So this is what it would look like. Again, it can be anything. It's a technique that is used. Is it very common? No, but I've seen several puzzles use this. Several ones out there that use this information. It's not as easy to make this, but certainly possible, and you cannot host it as mentioned on the Geocaching website. And finally, the true steganography. If you typically look at Google and you Google steganography, you will get a type of way information that says it's stored in the information in a way that is not visible to users and even hard to detect for a computer. There is not a simple tool that says this picture has steganography inside. Because what do these tools do? They make subtle manipulations to the image, slightly incrementing color numbers by 1 or 0, using space in the column numbers. Sometimes there's extra bits that they can use that are not used by the file format, and they can store information in that. In most cases, the file will be a PNG file. It's a very popular one for steganography, but it doesn't have to be. It could be an audio file, it could be anything. Important is that every website uses its own technique. There is no standard for this. So you kind of need to know the tool to know if it's there. And sometimes these tools require passwords. So that means that you not only know which tool was being used, but you also need a password. Never assume, even when you make a puzzle, that somebody will know what tool to use. As I mentioned, there's many different ones out there. So here is just some list of what a quick Google search brings out. And I have seen all of them being used in puzzles. Geocaching Toolbox, very popular website, has a steganography, has a pixel-based way of hiding information. But all of these sites do the same thing, but none of them are compatible with each other. If you encode it with one, none of the other ones can read it. So sometimes you have to try all of them. And this is only like 8, 9 of them. There's probably 20, 30 more of them out there. So if you don't know which one is being used, but you think it's being used, you have a big task in front of you. Try them all. So in most cases, I recommend that if it's a puzzle, that you kind of give a hint of which one is being used. Otherwise, it will be very hard to solve. So I did that for this puzzle. So take a look. I will show several of them and also show kind of like what they do if they are not used. So you kind of can see what to expect when there is something in there and when there is not something in that image. Let's look at the last part, the steganography. So this is the true way of encoding information into an image. Technically, all of them are right. All of these things that we've done is ways, but some of them are more open out in the open. This is truly like it's encrypted in the image itself. This is often done by using the pixels and by slightly changing the pixels in such a way that the eye can't see it, in such a way that it isn't consistent, that we can't use like the fill tools or anything like that, the color select tools. But we now have to use a website to do all the. There's many of them out there. I showed you some URLs. I told you which one to use, but sometimes you have to try different ones. Now I'll show some popular ones, but there is many of them out there. Some of them have other options. Some of them can do encryption. Let's take a look. The Geocaching Toolbox loaded the file, so select the file or can use a URL in this case as well. And if I press here submit, it will now analyze the file. This one just gives an error message if it wasn't encoded. So in this case it says it wasn't encoded. However, this one does support a password, so sometimes when you don't have the right password, you will see information but still encrypted. And so that way you know it's used, I just don't have the right password right. I can enter the key. But in this case, it just gave me a fatal error, so I know this wasn't. Let's go to the next one, Webble. Popular one as well. Again, uploaded the image. This one will download a file. So I press start here. It will just detect what it sees and it will show you that there is something going. Open this file, so it opens here a text file. And so here we see all these little symbols, but at the beginning we see that there's a slight deviation. So it says there's something going on. It didn't know what to do with it, but it did detect something was going on. So that could be useful. It may be a false positive, it does happen. But often this is one of the first ones I go to because at least then I know that there is something special. The one I used is the third one I've opened, Style Sucks website. Uploaded the image right here. And if I press decode, you will see hidden text found and then found it and show the information. So now we have the last number, but you saw it's very important that you use the right website. There's no other way to get this information on the right website, or you have to know exactly how it was encoded and way of doing it. So that's the last option. Again, quite popular, but yeah, you kind of hope to know the website. Otherwise, it's like a wild goose chase, and you have to chase all the ones that I just gave you, and there's many, many, many out that can do this. So we're getting to the end of this presentation. Certainly one of the more technology complex videos and topics that we talk about, very deep into the pixel formats, steganography, encryption. But here are some useful websites, right, that I used in the standard ones: Cacheloop, Geocaching Toolbox, Decode. Always try those. They have many techniques that I used here. You can do these websites. Getting EXIF information, file size, they all have tools for it. The magic eye, very unique feature, but if you think it's a 3D or a stereogram, that is the website to use. And then the two wizards, right? Photo forensics and a Solve. Every puzzler should try those and very familiar with those. They reveal so much information and can save you hours of staring at a picture. And then finally, if you don't have an editor available, pixlr.com is an online one, can do a lot of information. And if you're on the road, can be very helpful. If you don't have anything installed, need something more powerful, this is a pretty powerful. So that brings us to the end of the presentation. I hope you enjoyed it. This was a topic that was suggested to me that somebody would like to know more about. So if you have your own suggestions, feel free to contact me. If you have questions about what I explained, something wasn't clear, feel free to contact me. More than happy to elaborate one-on-one, and it also helps me. If you liked it, please press the like button. That will help other people find it as well. Subscribe. There's lots more videos. I'm also not only do longer ones, but I'm also looking at making shorter, couple of minute videos just about a single topic. And if you have a comment about something that you show here, please use the comment button right there. If you would like to contact me, you can do that through the geocaching.com website. I'm there as Waterfan5. Feel free to shoot me a message. I'm read it every day, so pretty quick to respond. If you have suggestions you would like me to talk about, maybe your puzzles, I'm happy to do that as well. Or you can also email me at geocacher.waterfan5@gmail.com. I read that as well, and you can send me more information. And with that, we reach the end of this video. I hope this was useful, and hopefully the next time you see a mystery cache, panic a little bit less.